Okay, in this session, we are going to demonstrate Morley triangle. So what that means is we are going to construct a triangle and construct trisectors of all the three angles of the triangle. And intersection of the outer trisectors for each angle, they form an equilateral triangle. Okay, so that's what we are going to demonstrate. So first thing we are going to do is just draw a triangle. Okay, so just draw a segment. Take another segment, and okay, and draw another segment. Okay, and now we are going to call this, label this point. A is fine, and label this point. B is fine, and label this point. C is fine. Okay, so we've got a triangle, so you can move around the triangle the way you want. Okay, so the first thing we are going to do is let's measure the angles. Okay, so I'm going to take AB and AC. So I want to measure the angle A. So I'm going to say measure angle. Then I got that. Okay, so then let's measure the angle B. Pick these two segments and then measure the angle. Okay, and similarly let me take these two sides and measure the angle. So I got that. Okay, so I've got three angles A, B, C measured. So then since we are going to trisect these angles, I want to find out the third of each one of these angles. So I'm going to number, calculate. I'm going to take that angle divided by 3. I'm going to calculate that. Okay, so similarly let me calculate this divided by 3. Say okay, so I got that. Okay, similarly I'm going to calculate that angle divided by 3, calculate that. Okay, so what I want to do is so I want to trisect each one of the angles. So let me trisect this. The way to trisect, so I need to pick the point and then the so let's just go here, transform, mark the center, so that's a center. And then I'm going to do the rotate. So I'm going to rotate. Okay. And then the angle, I'm going to rotate this way. Okay. Rotate. So I got that. Okay. So now I've got, this is 1/3 of the angle. So now I'm going to bisect the rest of it so I could get the trisector, right? So then now what I'm going to do is take these two sides and then construct angle bisector. Okay, I'm going to follow the same thing here. So then I'm going to do the transform, mark that as a center, and then take that side and transform, rotate. It's on the other side. I don't like that, so I'm going to just cancel that. So what I'm going to do is pick that point, transform, mark center, take this side and then transform, rotate. And the angle, I want to rotate this angle. Okay, rotate. Okay, so now I want to bisect this angle. So take these two and then construct angle bisector. Got that. Okay, so I'm going to follow the exact same process here and transform, that's mark the center, and then pick the side and then transform. I'm going to say rotate, and it's outside. I don't like that, so I'm going to cancel that. So I'm going to again pick the point, transform, mark the center, and then take the other side and say rotate, and then mark the angle. I want that angle, rotate. Okay, so now I need to bisect this angle. So construct angle bisector. So now we've got all the trisectors. So now I'm just going to take the outer trisectors. For example, I'm going to take this, and then construct the intersection. Okay? So now, similarly, I'm going to take this, outer, this, and then construct the intersection. Okay? So similarly, take the outer, and construct the intersection. Okay? So now what I want to do is I just want to connect. So I'm just going to take the segment tool, connect these intersection, right? Okay? Connect this and that, okay? And then I'm going to connect again this and that, okay? Like that, okay? So now I want to measure. So I want to measure the length of that. Okay, got it there. And similarly, I need to get the measure of that, length of that. Got that, okay? So similarly, I want to get the measure of that. Right. So now I've got all the three measures, right, of the DEF. You see that all the three measures are exactly the same. So DEF is an equilateral triangle, okay? So now, when I move this triangle ABC, I can move any way I want. You watch DE, EF, and DF. It's always an equilateral triangle. You see that? So DEF, no matter how I change this triangle, DEF is always an equilateral triangle. So with this, we have demonstrated the Morley triangle. Okay?